Boys and girls, I'm Mr. Chow. Please have a look at the yellow box here on the screen. In this video clip, you should be able to state one of the three processes of heat transfer, which is convection, and give three examples of application of convection. The screen showing up to you here is exactly the same as your book. So turn to page 107 now. Prepare yourself also with a pen and write down the aim shown here anywhere on page 107. Press the pause button now to stop this video. Continue when you are done writing down the aim. Now, let us have a look at one of the three processes of heat transfer, convection. Convection. Liquids and gases flow. Thermal energy can be transferred in these materials through a process called convection. We will study this heat transfer process in the following part. Heat transfer in liquid and gases. First of all, we will have a look at an experiment or practical. The aim of this practical is to observe convection in water and air. Now, let's have a look.
Gently warm a beaker of water with a small Bunsen flame. Carefully put a purple crystal into the water near the beaker wall. Observe how the colored water moves. Put a candle in a beaker near the beaker wall. Light the candle. Put a piece of T-shaped cardboard across the beaker. Light an incense stick and put it into the beaker as shown. Observe the movement of the smoke.
Answer the question now. Press the pause button now to stop the video until you are done with the answering. Now here is the answer. You should draw the arrow in the diagram on the right to show the movement of the color water. You should draw the arrows in the diagram to show the direction of movement of the incense smoke. Let us continue. In part 1 of practical 5.8, the water near the flame becomes hot and rises. The cold water in the surrounding region sinks and moves in to replace the hot water. It is then heated by the flame. In this way, all the water in the beaker is heated gradually. This heat transfer process is called convection. As you can see in the red and blue arrow, water near the flame becomes hot and rises. Cold water sinks and moves in to replace the hot water. So this is the convection in water. And convection takes place in air in a similar way. As you can see in the red arrow, air near the flame becomes hot and rises. Cold air moves in to replace the hot air as shown in the blue arrow here. In daily life, you will experience wind. The wind is caused by the temperature difference between the land and the sea. Next page. In convection, hot liquids and gases move upwards. In other words, thermal energy is transferred upwards. This can be demonstrated by putting your hand above a candle flame and the other hand beside the flame. The hand above the flame will feel much hotter. Convection is affected by many factors such as the positions of objects. This will be discussed in the coming section. A brief summary here. Convection takes place in liquids and gases. Thermal energy is transferred upwards by the movement of the liquid or gas itself. Now we will move on to the second aim of this video lesson. We will discuss 3 examples of application of convection. A. Convection heaters and air conditioners. A convection heater is usually placed on the floor. When it is turned on, air near the heater heats up. The warm air rises and the cold air in the surrounding region sinks. The whole room is warmed gradually by convection. An air conditioner should be installed high on the wall. It gives out cold air. The cold air falls and pushes up the warm air. The air conditioner takes in the warm air and cools it. As the process continues, all the air in the room is cooled. Well, if the air conditioner is installed near the floor, convection can only occur in the lower part of the room and the whole room cannot be effectively cooled. Monitors. Usually there are slits at the back of a monitor. When a monitor is turned on, thermal energy is given out. Air inside the monitor warms up and rises. The slits allow warm air to leave from the top and cold air to enter from the side. This cools the monitor by convection. Electric kettles. The heating part of an electric kettle is fixed near its bottom. This allows water to be heated by convection. If the heating part was near the top of the kettle, the water at the bottom would heat up very slowly, even if the water near the top was boiling. Do checkpoint 4 now. Press the pause button. Continue this video when you are done. Now here are the answers. 1A. Convection can take place in solids, liquids, and gases. The answer is false. Convection cannot take place in solid. 1B. Thermal energy is transferred in all directions by convection. The answer is false too. Thermal energy is transferred upwards by the movement of liquid and gases. 1C. Air flows when it is heated. The answer is true. Have a look at this answer. This is the direction of water flow. Question 3. Mary prepares the following setup. She heats the top part of the water as shown. The ice does not melt even if the water at the top is boiling. Explain this by completing the following sentences. Water is a poor conductor, so little thermal energy is transferred through the water to the ice by conduction. The ice is kept below the heated part by the wire gauze, so thermal energy cannot be transferred to it by convection. Summary. We have learned one of the three processes of heat transfer, convection. Convection takes place in liquids and gases. Thermal energy is transferred upwards by the movement of liquid or gas itself. Three examples of application of convection: convection heaters and air conditioners, monitors, electric kettles. For homework in this lesson, please do workbook page 42, question 3. That is the end of the video lesson. See you around.